Hello, welcome to week 3 of our class Plane and Spherical Trigonometry. Our topic for this week is course and bearing problems involving plane right triangles. The course outcome for this week is still CO1, solve problems related to plane right triangles. And the learning outcomes for this week is LO 1.5. Solve course and bearing problems involving plane right triangles. Course and bearing are two important terms used in navigation. Calculating for course and bearing is one of the most common applications of trigonometry in navigation. In this lesson, the techniques in using plane trigonometry to solve course and bearing problems are discussed. Today, modern ships are equipped with powerful computers and navigational aids that automatically calculate real-time course and bearing values of nearby ships and objects. Why do you think that you need to learn how to manually calculate course and bearing despite having computers and navigational aids that do it automatically? Let us start our discussion with course. Course is your intended path or the actual path that your ship is traveling. The heading is different from course because the heading is where your ship is pointed. The heading may be different from course because of drift and other external factors. Bearing, on the other hand, is defined when you consider point B from point A. So this is point B from point A in a horizontal plane. The angle made by the ray drawn from A through B and the north-south line through A, that's your bearing. So this is the north-south line and this is the line from A to B. The angle between those two lines is the bearing. The bearing is then read from north or south line towards the east or west. The angle used in expressing a bearing is usually stated in degrees and minutes. So for example, you can see that an object at point B from point A will have a bearing of 35 degrees east of north, or you can write it as north 35 degrees east. Since this angle is 35 degrees and the line from A to B is at the east side of the north line. Similarly, if B is over here and A is over here, then we can say that the bearing of B from A is equal to south 35 degrees east or 35 degrees east of south, because the line from A to B is 35 degrees away from the south line. Similarly, on this third example, the bearing of B from A is 35 degrees west of south, written as S 35 degrees W, or south 35 degrees W. And on this last example, point B from point A has a bearing of 35 degrees west of north. What if you are in ship B? What if you are over here and you want to know the bearing of A? You want to know the bearing of ship A from ship B. Then using geometry, we can deduce that this angle is also 35. So the bearing of ship A with respect to B would now be 35 degrees west of south, or written as south 35 degrees west. So take note that it depends on where you are standing, what is the point of perspective from, and which one is the object that you are trying to ascertain the bearing of. In navigation, the bearing of B from A is more often given as the angle made by the ray AB with the north line through A, measured clockwise from the north around through the east. For example, these are similar examples from the ones from the previous side, but you can directly write the bearing as 35 degrees, and for the second example 145 degrees because it's measured from the north line. This is 145 degrees. So in this case, this is 90 degrees, and on the fourth quadrant it's 35. So 90 plus 35 is equal to 145. Using the same concept, starting from the north, the bearing of B from A is equal to 215 degrees. And on the last example, this would be on the previous slide, this was written as 35 degrees west of north, or north 35 degrees west. But now it has a bearing of 325 degrees. So try to compare those two. Bearing is an angle measured clockwise from the north direction. So in this example, the bearing of B from A is 25 degrees. Since from the north line, so the bearing of ship B, if you are standing on ship A, so the bearing of B is 25 degrees from the north line. Meanwhile, if you are in ship B, if you are here on ship B and you want to know the bearing of ship A, you measured it from your north, so that's 205. Let's try to answer this example problem so you can apply what you have learned so far. The question is, A, B, and C are the locations of 3 ships. A, B, and C. The true bearing of A from B. So the bearing of A from B is 45. Let's try to draw A. So since it is from B, then you are here in ship B. So this is the north line of ship B. You measure 45 degrees from the north line. 45. So that's the bearing of A. From B is 45 degrees. Next, the true bearing of C from A is 135. So take note, from A. So if you are from A, you are here at A. C is 135. So where is C? This is your north. This is 90. This is 180. 135 is right here. That's 135. So that's 90, and this is 45. We don't know yet the other angles. The length of side AB is equal to 8 km. So AB, this is side AB, so this is 8 km. And AC is 6 km. This is 6 km. What is the distance of ship B from ship C? And what is the true bearing of ship B from ship C? So we have to solve for all the relevant angles and all the relevant sides. To help us in solving this problem, let's try to use geometry to deduce other relevant angles that we can use in our solution. So again, let's draw. This is ship B, this is ship A, and this is ship C. We know that from B to A, the bearing of A from B is 45, and the bearing from A to C is 135. So we can ascertain that using geometry, this is a 90-degree angle. So 135 minus 90, this angle is 45. We also know that this angle is 90. Then since this is 45, then 90 minus 45, this is also 45. Now since these are both parallel, so using geometry, this angle is equal to whatever the measure of this angle is. So since this angle is 45 degrees, then this angle is also 45. So as you can see, we now have two 45-degree angles side by side. That means that this is a 90-degree angle. So now we have a right triangle, because that is a right triangle has a 90-degree angle. In this case, the 90-degree angle is at A, and the given are the two legs or two sides with lengths of 8 km and 6 km. The hypotenuse is unknown. Let's try to solve for the other internal angles, or the angles at B and at C. So since we are given two sides, that would be opposite and adjacent, whichever you choose to be as your reference point. So if you're looking at, if your perspective is from B, so your angle, since it is opposite and adjacent, we use tan. We don't use cosine and sine because the hypotenuse is unknown. We use tangent because the opposite and the adjacent sides are given, which is 8 and 6. So tangent of angle B is equal to opposite over adjacent. So the opposite of B is 6, and the opposite of the adjacent side of B is 8. So you can solve for B by typing in your calculator B tangent. You can directly type in your calculator the inverse tangent, 6 over 8. Therefore B is equal to 36.86989 degrees. Similarly, we can solve for angle C using the same process. Tangent C is equal to opposite over adjacent. The side opposite to C is 8 over the side that is adjacent, which is 6. So using the same process, C is equal to tangent inverse of 8 over 6. So C is equal to 53.12 degrees. Now since we have two angles already found out, this is 36, yeah, 36.87 and the other one is 53.12. We can easily solve for the hypotenuse. We can either use the Pythagorean theorem, or since our topic is about trigonometric functions, we will try to use trigonometric functions. You can use either sine or cosine to find the hypotenuse. Let's try sine. You can choose either sine 36 or sine 53, whichever you like. So let's try sine 36. Sine 36 is equal to opposite over hypotenuse. We are looking for the hypotenuse, so we transpose the hypotenuse and sine. You can exchange them. So hypotenuse is equal to opposite of 36 is 6 km divided by sine 36.87. If you try solving that in your calculator, you can get a hypotenuse of equal to 10 km. So we have solved the distance of the ship from B to C. That's 10 kilometers. Now let's determine the true bearing. The true bearing of ship B from ship C. So if you are from ship C, how many degrees is ship B? Let's try to draw an axis. So this is easily from the north line to the south line. That's easily determined because half of 360 is 180. So since that is 180, we just need to determine the angles for the remaining angles. So since these two angles are, or these two lines are parallel, so if this is 135, then this angle is also 135. Since this is 53.12, we can deduct 135 minus 53.12. That gives us a remaining angle of 182.12. Or 81, sorry, that's 81.87 approximately. So if this is 81.87, and since we are measuring from the north line, so that's 180 plus 81.87, that's a total of 261.87. So that's our answer for question B. What is the true bearing of ship B from ship C? So our answer for this problem or this question, the distance between ship B and ship C is 10 kilometers and ship B has a bearing of 262 degrees from ship C. For your exercise problem, try to answer this question. A dry bulk cargo carrier ship departs from a port and sails on a course of 78 degrees for 4 hours at a speed of 18 knots. The ship then alters its course to 168 degrees and sails for 6 hours at 16 knots. After 10 hours, what is the distance of the ship from the port? And what is the bearing from the port to the ship? Try to answer this question. Write it down in your notes. Try to apply what you have learned in this week's discussion. For your evaluation for this week, you should be able to solve course and bearing problems involving plane right triangles. So simply go to the week 3 classwork posted in the online classroom for NGEC 9 plane and spherical trigonometry. Thank you for joining me in this week's discussion. Next week, our topic is applied problems involving plane right triangles.